Right, so in this class, they said we'll focus on the assignment 1 for Math 11, for Math 2100, that's analytical geometry and calculus. But even as we focus on question 1, those that are registered, I'm sure you have full access to the rest of the other questions for this assignment. Of course, there are 3 questions, and this is only question 1. And these questions are kind of long and quite involving. So I hope I have everybody's attention, but you're free to ask at any time. So the question reads, transform the equation of the conic and in standard form and hence identify. So key, after all this, we have to identify vertex or vertices, focus or foci or directrix. So we have to focus, then we have to what? We have to sketch. So that's gonna be our focus or our aim for the entire thing. Now, how are we going to know this? First of all, so our equation is given 4xy squared plus 4xy plus y squared minus 60x plus 120y is equal to what? To 0. So I can actually identify this equation from the look of it. I can compare this equation to the standard equation, which I know the standard equation is written as. So the standard, we know it's ax squared, x squared plus bxy, then plus cxy plus dx plus e y plus f, this is a constant, equal to 0. So this is the standard. So now in most of what you've been looking at now in class, it has not been involving this term, which is the xy term. So now in here, what is making this question kind of involving is this same xy term. So we don't know, or we can't really evaluate this. We don't know whether you have to group it to factorize it with the y or factorize it with the what, with the x. So you have to what? You have to instead transform by what? By rotation. But now a good thing that you'd want to note is, so you can note that if we are finding, remember when we do the discriminant test, if we say b squared, so b squared minus 4sc equal to what? So this here is being the discriminant test. And if this here is equal to 0, then we know we have a what? Parabola. Then b squared minus 4ac, if what value we get here, yes?
So, sir, can you just repeat what you're saying from, is it determinant?
Here on the discriminant test?
Yeah, discriminant test, yes.
Okay. So, what I'm saying is, okay, so I'm sure you remember this part here from first year, the part where we use the discriminant test, and so okay, somebody has their mic on. Can I ask if you can mute your mic? Yeah. So this b squared minus 4ac. I think you remember this from first year, but now here, how this can be useful in helping us identify the kind of equation we're working with is always when we from our standard equation, we can get the b, we can get the a, and we can get the c. So then when we find this we plug in those values, and if that is equal to 0, then we know that our equation is going to be that of a what? Of a parabola. Then if we plug in these b, a, and c, then we find that this is less than 0, then we know that we are going to either get an ellipse, getting an ellipse, or a what? Or a circle. If that is going to give us that way. Then if we have b squared minus 4sc, this being greater than 0, then this gives us a what? A hyperbola. This gives us a hyperbola or intersecting what? Intersecting lines. And you know, intersecting lines are just degenerate hyperbolas. Yeah. So those are just degenerate hyperbolas, that will form intersecting lines. And those intersecting lines, for a hyperbola that is normal, the intersecting lines are usually called the asymptotes. So now if you just have a case where you don't have those things, so a hyperbola looks like this. You don't have this, instead you just have the lines crossing. These are, that is when maybe this discriminant test is greater than what? Than 0. So the first step here we're going to take is to actually identify what are we working with first. What kind of equation is this? So let me wrap this. Okay, so the equation now, I must identify what kind of equation I'm working with here. So I can see here. So what is important is for me to have my A, my B, and my C. So my A from here is 4. You can see that. My B is also what? Is also 4. And my C here is what? Is 1. So my C is equal to 1. Then I can replace this in this discriminant test where I say B squared minus 4AC, and see what I'll get. So where there's B, I'll put 4 squared minus 4. Where there's A, I'll put 4, and where there's C, I'll put 1. So this gives me 16, and that gives me also 16, and this gives me 0. So because I've gotten 0, I know from what I had just written earlier that this equation is actually going to be an equation of what? A parabola. Now, if it's going to be an equation of a parabola, how do I then continue from here? What am I going to what? What am I going to do? So when you're rotating or when you're transforming, these things are transformed at what? At an angle. There's an angle at which what you're transforming your equation. So now that angle, in our case, that angle is not actually what? Is not actually been given. So there are times they tell you, no, transform it at an angle 45, maybe at an angle 60, at an angle what? But now, because we've not been given, we have to what? We have to find our angle. So now this is where such a formula, okay, let me make a new page. Okay. So the formula, there's a formula that is very important that you have to what you have to remember. And this formula is written as tan 2 theta equal to B then A minus C, or it can be written as cot 2 theta equal to A minus C over what? Over B. So now after get this is what is going to help you to what? To identify your angle. If you've not been given what? You've not been given an angle. So this is what you use. So now you can either use cot or this. You know that cot just being the inverse of tan. So, and this is why these are just swapped here, because it's what? Just the inverse. Myself, I like using tan, so I'll just go into the tan one and say tan 2 theta. What is my B? So I know my B from my equation earlier written is just 4. And my A is also 4, and my C is 1. And this just gives me 4 over what? Over 3. But this is going to be useful. How? If I draw my right angle triangle like this, and I say I have an angle here, and this angle is actually 2 theta. So if this angle is 2 theta, from here I know, oh, what is my tan? My tan is actually opposite over what? Opposite over adjacent. So I say my adjacent to be here. So meaning my opposite is actually going to be here, and my adjacent is going to be there. Oh, 4, 3. And the longest side is the hypotenuse. I can actually find this easy, and this is a 4, 3, 5 triangle, which I know, okay, when you square this, square that, add them, that's going to be 16 plus 9, and root of that, which is going to be root of 5, just gives me 5. I know you guys know how to do this. So now this gives you 5. Now after giving you 5, that is going to be useful. Why? Because when we are transforming, so when you're transforming, what you must consider is you're changing your axis. You're moving from the normal axis like X and Y, to a rotated axis. And that rotated axis is just denoted by what? Y and X prime and Y prime. So when you're dealing with this, you know that your formulas that you use to move from X coordinates to this Y prime coordinates is just going to be, so X is given by X prime cos theta minus y prime sine theta. Then your y is given by x prime sine theta, then plus y prime. This is just going to be cos theta. So this is how you're going to transform. But now as you're transforming, you see there are these angles here. You have you have cos theta and sine theta. So now you need to make sure you get those cos theta and sine theta. So now how we obtain them, we use the same what we're trying to do here. So we'll come back to this part, but let's for now just erase it and then we continue with what we were doing. So now after we get this, it means I can get my cos angle, like cos 2 theta angle, and also my sine 2 theta angle. So I know cos is just adjacent over hypotenuse. So meaning cos, the angle is what is actually 2 theta. It's just going to be adjacent over hypotenuse, gives me 3 over what? Over 5. And my sine 2 theta is just going to be opposite of adjacent, opposite, I mean over hypotenuse, because so are opposite of hypotenuse, and that gives me 4 over 5. This is keen and to understanding that, uh, okay, since I have this 2 theta, but I'm not interested in actually the 2 theta. If you saw that there was cos theta there was cos theta and not cos 2 theta. So cos theta and not cos 2 theta. So I need to get my cos theta. But for my first year, I remember the formula that, oh, cos 2 theta, I can actually find my, if I have this cos 2 theta, I can find my cos theta using the formula where I just say this would be root of, then I have half. So I have half, then 1 plus, 1 plus, that would be cos 2 theta. 1 plus cos 2 theta. So I know I'll get something like that, And then to find sine theta, I just have to say this is going to be half, then I have 1 minus cos 2 theta. So these formulas are keen to remember as we are doing this. Okay, so now what do I do next? I don't want to erase our work because I'll have to come back to it. So we create a new page. So our cos theta now is going to be equal to, okay, I write that. So I have half there, then add 1. Okay, I already had found my cos 2 theta, which was just 3 over 5. And I can evaluate this. So this here inside gives me, this gives me what? Gives me 8 over 5. And 8 over 5 multiplied by half, that just reduces to like 4 over 5. And you have 4 over 5 here. And this is just going to give you, on top here, root over 4 gives you 2. And down there you get what? Root 5, since you don't have a perfect square. So that gives you root 5. Okay, after getting root 5, what do we do next? So from here, I find the one for sine. So sine theta is going to be equal to root, then you have 1 there, then you have 1 minus, so you are using, it's cos 2 theta. That's what's given in the formula, so that would be 3 over 5 here. And this inside here just gives you like, this gives you 2 over 5, then 2 over 5 multiplied by half just gives you 1 over 5. So this here is going to be 1 over 5. Square root of 1 gives you 1. Square root of 5 gives you root 5 now. So this is what you get to be your sine theta and your cos theta. So now after getting these two, you now want to do your transformation. So remember the formula which we had saying x has to be equal to x prime cos theta, then minus y prime sine what? Sine theta. Then your y has to be y equal to, this is going to be y prime sine theta, then plus y, yeah, y prime. This is x prime, so not y, x prime sine theta plus y prime cos theta. So now after getting these two, you want to now just plug in what you just from getting, and so you know that your, so this here is your angle, and yeah, you replace there. So that's just gonna give you 2 prime over what? Over root 5. 2 prime over root 5. Okay, then there it's 1. 1 multiplied by the y prime gives you y prime over again that root 5 there. Okay, this is what you get. After getting this, what can I do with this? I can actually join this. They have the same base. So this is just be like x prime minus y prime divided by or by root of 5. Okay, good. Then I do y. So why I do the same and I replace there, I just get x prime over 5 over root 5. If you have any question, feel free to ask. Then you just have plus there to be 2y prime over root of 5. Then I can join this. So if I join this, how do I do that? I do that easily. That's gonna be, this is just gonna be equal to, then this is x prime plus 2y prime over root 5. So I've joined these two. After joining these two, then what am I going to have? Uh, so what am I going to have is, okay, just a moment. All right, so what I'm going to have now from here, what do I do? What I go back to that original question that's given in the formula, and that that uh, that that equation, what do I do? So where there's x and where there's y, I'll be replacing just like that. So where there's x, I replace with what I found to be my x, and where there's y, I replace with what I found to be what? To be my y. And that is just going to what? To work out for me like that. So let me make another page. So yeah, let's now replace. So remember you have your 4 and your 4 it's x squared. So the value that I found for x squared is like 2x prime, then minus y prime, then divided by root 5. Then this is squared here, the entire thing is squared. So then from then I move on to the next one. So the next one then is going to be, so the next one is 4 again. Now it's 4 with that xy term. So the xy term, actually, this whole doing is just for us to get rid of this xy term, because we don't actually know how are we going to work out. We don't really know what this xy term is. So, or which part to group it with. So we get rid of it. This will be plus 4. So what you can do is you can actually do them in sessions where you say, okay, you get this, your 4, then you work out this. After working out this, then you actually what? You evaluate for this, then you do the next one, then you just come and combine everything together. Or you can be replacing them as you go to say, where there's my x, I'll replace the value which I found, which is 2x prime minus y prime over root 5. Then I close, then I open. My y is actually y prime plus 2y prime divided by root 5. Okay, so this is gonna be easy. Then this is gonna be plus. Then I have a y squared. Oh, y squared. Okay, so that's gonna be xy prime plus 2y prime, then divided by root 5. Then I square this. Okay, what's my next term? My next term has a minus first, then it comes 60. Then I have to replace because it's 60x. So I replace my x. So x prime minus y prime, then divided by root what? Root 5, like this. Then the next one has a positive 120. 120, then that is going to be x prime plus 2y prime, then divided by root 5. Then, okay, this whole thing goes to 0. Now, I want to do something here. I want to be kind of, I don't know if I say a bit clever on this. So you know this squared can distribute with what is on top. So if it's what's on top, you can write that as x prime, like this, minus y prime, then you squared. Then down there, you square your what? 5, like this. Then this just gives you 5. So now, I'm not going to take the lecture of just writing all that because it's going to be a lot. So what I do is I have my 4 there. I know when I square this, because of that squared, I get 5. So I factor that out. Just remove it that. Then I work out what's inside. So I multiply this 2 x prime minus y prime. Since it's squaring, it's like this, meaning I'm multiplying this by itself. And I know how you guys, you know how to expand this. So you expand that, then what you just get there is so what you get there, you're just gonna have inside that'll be a 4x prime squared. Then you have minus 4x prime y prime plus x prime squared, like that. Then you do the same for that one. You can factor out the 4, 5. Then you just have 2x prime squared. Then that will be plus 4x prime y prime minus x prime y prime. Okay, then that will be minus 2y prime squared. Then you close. Then plus, factor out again 1 over 5 this time, because here you see when you square down there you get 5, and you can factor out a 1 over 5, which is going to be there like that. I know you guys know how that is coming about, but if you're confused, you can ask. Yeah, but we continue there. That's gonna be x prime squared plus, then you get your, what do I get? Yeah, I get my 4x prime y prime, then plus 4y prime squared. And next there, what do I get? I can factor out. So you have a 60, then you remove that root 5 there. This time it's not squaring, because you see you just have the 2x prime minus y prime there. And that's the same for the 120 root 5. That looks good. Then you have your x prime plus 2y prime. Then, okay, that all is just going to 0. Okay, so this is what you get. After getting that, what next? If the video, or not if the video, but if this class actually cuts, you just rejoin using the same link. Yeah, rejoin using the same link. Now I'm gonna use different color from here, such that as we progress, you guys just don't get confused there. So what can I do now next? So after doing that, I actually wanna be smart about this. So look at this part here. So you have your 60 here. You have this part here, this part, and that part. They have roots. But from first year, actually, I understand that I can actually rationalize that. And if I rationalize that, I just have 60 to be like 60 root 5 divided by what? Divided by 5. Then I can do the same there. I have 120 root 5 divided by 5. That way, every term here, you actually have a 5 there, 5 there, 5 there, 5 down, 5 down. And that would be easy to work with. How? When I multiply by 5 throughout, those 5 there divide. They'll cancel out. And what I just remain with, so I know you won't get lost because I've explained. So when I multiply by 5 throughout, the whole thing here multiplying by that 5, those 5 divide. And I just remain with 4. There at first, I'll just have 4x prime squared minus 4x prime y prime plus, that's going to be y prime squared, and plus, then I get 4, that's going to be 2x prime squared plus, this here I can subtract, so that gives me a 3. So I get 3x prime y prime, then that will be minus 2y prime squared. Okay, that looks nice. Then that's going to be here, actually, that gives me 1. So 1 multiplied by whatever I have, I'm just going to have that same thing, like x prime squared plus 4x prime y prime plus, that's going to give me 4y prime squared. Okay, that looks good. Then the next part is just going to, because you've cancelled that out, you've multiplied, this gives you negative. You have a negative here. That will be negative 60 root 5. So root 5, remember the root 5 where it's coming from. Then you just get, that's going to give you a 2x prime, then minus y prime. Okay, Then the next one is plus, then 120 root 5. Then that gives you, you have your x prime plus 2y prime. Okay, then we get this thing, and this is just all equal to 0. Then, yeah, that's what we get. Now, after doing that, we can actually now expand. So we can expand, multiply your this thing. 4 by 4 gives you what? This actually gives us 16 x prime squared. Then that gives you also negative 16x prime y prime. Then that gives you plus 4 y prime squared. Okay, then next here you get that will be plus 8x prime squared plus 12x prime y prime minus, that gives you 8x prime squared plus, that will be x prime squared. Yeah, I'm not rewriting this part here. So it's gonna cut the video, as I said, it's gonna cut in the next 10 minutes. So just rejoin using the same link. So that gives you the 4x prime y prime you're looking for, which is there. Then of course plus that 4 y prime squared. Then you can distribute that, and what do you get? You multiply that, you see 2 by the 60 gives you 120, so you get 120 root 5, and root 5 what? X prime. Then there gives you plus 60 root 5 y prime. Do the same there, that will be plus 120 root 5 x prime. Then that gives you, multiply it by 2, that gives you, then gonna be plus 240 root 5 y prime equal to 0. Okay. Whew. That. All right. Then from here, what you're going to get is, you group the terms now. So you group the terms, you look at the terms, which ones are subtracting, which ones are adding. So let's start with the a is x squared. So you see, this one has x squared. Which was that one? This one has x squared. This one has x squared. So they are 1, 2, and 3. If I add them, that's 16 plus 8 plus 1. And I just get this, gives me 25. And that would be x prime squared. Next, I go to the xy term. I have negative xy. Here, positive xy. That's 12. That's negative 16. Where else do I see that xy? Oh, here. You see, you add this 12 and this 4 gives you 16, and this negative 16, so that's going to be 0. So because it's 0, it cancels out that xy term that we wanted to be gone. Okay, that's good for us. And next, what do we have? We have this part. This is the y squared. So y squared, that one here has a y squared. Which one? This one here has a y squared. So this y squared plus that y squared gives you 8y squared. Oh, then this is a negative y squared. That also goes to 0. So beautiful. Then what do we remain with actually now? Oh, these ones we've not underlined. Okay. This one. Oh, this one is negative 120. This is positive 120. So why? This gives you 0 as well. So those just cancel out. Then you just remain with this one and that one. You can add these two, and that gives you the positive 300 root 5 y prime equal to 0. That then makes more sense. Then what can I do here? I can actually take this side, this on the other side, and have x prime squared. That's going to be negative 300 root 5 y prime. Then I can divide here by 25. I have x prime squared. It's going to be equal to, that's going to be negative 12 root 5 y prime. Okay, now at this stage, you actually have confirmed from the first working which we did when it gave us 0, and we concluded, oh, that the parabola, it's actually a parabola. And now we actually see the equation, because this is x squared negative what, and you have a y there. This is just the general form of what? Of this parabola. And I can write it to say this is just x prime squared. And you know that factor out that 4 because general form 4, then you have your c. So my c then there, 9 divided by 4, this is negative 3 root 5. And you have your what? Your y prime. So your c here, 4 y prime x squared. In the general form, parabola looks good. Okay, now how do we progress from here? So I have to find my focus and my directrix and all those things that I might. Okay, unwrap here. Unwrap this here, erase this, erase this. Okay. So now my c. So I said my c is gonna be this. So you know your c is gonna be negative 3 root 5. Okay, how do I find my focus? I know it's centered at 0, 0. You can see here there's nothing. Yeah, there's nothing. So it's at 0, 0. So I just now add in what axis is it? It's in the y-axis. So I add center, which is 0, 0. Then I add my focus there. So I add my c, I mean. So I add it in the y, and that's gonna give me that my focus will just be equal to 0, negative 3 root 5. Then I know that my y, which is my directrix, is just going to be equal to, so this is the focus, and your directrix is just going to be, so my directrix is going to be negative c, and so c here when I replace, I'm just going to have to be positive. So this changes to be positive now. This will be y, and this will be 3 root 5. So this is going to be my directrix. Okay, I don't end here. Reason is this here, what we found, remember, is in the x prime, y prime coordinate system. But I do not want it to be in the x prime, y prime coordinate system. I want to get my x and my y prime. Not my x and y prime, but I want to get my x and my y such that I can be able to graph it on the xy plane instead of graphing it on the what? On the x prime y prime plane. Okay, so how do I do this? So I have to change. So that's my focus. So what's important is the focus and the directrix, right? So now how do I do this? From here, I just replace. Now I plug in. So remember those formulas that we said. So y, we had something like x equal to what? To 2 this minus this prime over root 5. So this was our x, and our y is just our y was x prime plus 2 root it's 2 roots, but 2y prime root 5. Okay, so getting that, then I can replace that. So for my focus, I get, so what is my x prime? It's 0. So this whole entire term goes to 0. Minus 3 root 5 over root 5. And that just gives me 3 over root 5, root 5. Oh, nice. And this divides, and I just remain with 3. Do the same with y. And I get with y, gonna give me 0 for x, and my y is gonna be negative. All right, so then saying this is gonna be negative 0, then you got, no, not negative 0 plus, then that gives you, there's a 2 here. Yeah. and your y prime is negative 3 root 5, then over root 5. And this is gonna be, so that would be negative 6 root 5 divided by root 5. And this gives me 6. So meaning my focus in the xy plane is just like 3 comma negative 6. You would even guess that after getting negative 6 here as your focus, your directrix is probably just going to be positive that. And yeah, it's actually going to be positive 6. You can plug in the same and you just get positive 6. Okay, so getting these values now, let's make use of them. So I think we've actually answered up toward part of this question. We go back. Okay, so we continue from there, and yeah. So what I was saying is, by now we've answered actually the whole part of these questions. We found the vertices, we found the foci, and we've also found the directrices because we have two of those. So after finding those, what do we do next? Unless there's a question up to this point, you really want to ask a question that's burning before we actually just speak and call it a day. Okay, so uh, all right, let's now just finish up. Okay, okay. So we go back to the last slide, and okay, so this is where we ended, and so what we're getting from here is that we've just found our focus to be 3, negative 6, and our directrix to be positive 6. And after getting that, so you draw your xy plane. This is your y. That's your x, right? Where is this 3 comma negative 6? So remember that we found that our graph for that y prime, the x prime squared, was equal to negative 12 root 3 y prime. Yes.
I didn't really get where you get the value 3 comma negative 6 and
Oh, this 3 comma negative 6? Okay. Okay, let me just take you a bit back to the previous slide. So this is the previous slide. And so remember, the reason why we changed our axis, we did a kind of, let's say, a rotation of axis, where we changed our axis. We were in the xy plane. Then we changed to looking at another axis. Maybe we're calling a y and x prime, y prime plane. So now we use that one in order to get rid of that xy term which we have in our equation, because we don't know how to work with that xy term if we have it. So we need to get rid of that. And we worked out even from the beginning and we understand that the equation that we got is that of a parabola. But even as we got that question and that equation, we are told we want to graph this in the xy plane. So now for you to graph it in the xy plane, what you must do is to take it back in that xy plane. So remember that your x value and your y value is given by this. And this is what we're just from finding these, your f and your c. These are x prime y prime values. So now you need to go back to that x and y, not the prime. So now you replace in these. And when we replaced, we worked out and got 3 for the x coordinate that is there. And I did the same for the y coordinate, replaced here, and I got negative 6. So this is where now this gives me the focus in the xy plane. And that's where I get it like that. And my y as well. So for my y, if I replace there, if this is my directrix, right, which is this one here, if I replace it in the y there, this directrix, does it have an x part? No, so the x is 0. Then I have 2, my y prime. This is actually my y prime in this case. So it will be 3 root 5 divided by root 5. Then I just remain with 6 root 5 divided by root 5. This goes, then I just have 6. So meaning my directrix in the xy plane is actually y equal to 6. So now I have these 2 points. I hope it's clear now how we get those points. Yeah, so I have these 2 points, this being my focus in the xy plane. So remember we found one in the x prime y prime, yeah, y prime plane. So this is my x and y prime, my x and y plane. So this is why that's why the question is asking for focus or focuses, like, yeah, because you can actually, we've had we've had 2, one in that plane, one in this other plane. But my concern is here, we have a negative sign, and this means, of course, it's in the y. So even here, we have to graph it in the y, like in the y. But then, because it's negative, it means it's going to face down. So where I go to where my 3 and my negative what is. So if 3 is here, for example, 3, let's say 3 is here, that's where my 3 is. I know negative will be going down. So let's say our negative 6 is somewhere here. So there. So this here is going to be my point of my focus. Then my directrix, let's say 6 is what? Is there. So my directrix is actually cutting the line, cutting there, like that. Okay. There. So that is y equal to what? Equal to 6. But then where is my vertex? So my vertex, did the question really even ask for vertices? I don't know. But okay. Your vertex, remember, is centered at 0, what? 0. That was this here, as we can see here, it's at 0, 0. But now, because this has a shift, you see where like your values, so this is your values of x and y in the focus. That's for the focus and not the vertex. But we know by definition of a parabola that the distance between the focus and where your vertex is the same. Even the distance between that, your vertex and your directrix is going to be the same. So now, which means our parabola is just going to sit at the vertex where we have 3, 0. 3, 0, and that is going to be, let me draw it in a different color. It's just going to be like this. Yeah, something like this. To it better, let me just try to, okay. So, of course, it can go like that. It doesn't really matter. We know our concern is not really on the x or y intercepts, whatever. But yeah, so just to show this. And this is sketch. All right. I guess we are done, unless there are any questions. Mm. Is that a question?
No, sorry, sir. Well, for taking me back, please. I didn't get really on how to do the testing using the discriminant.
Oh, okay, okay, not a problem. So, basically, what I was saying is, let me try to make a page for you. So, what I was saying is, you have this. Remember this test that we did in first year. Though our concern really is not like the way we're applying it in first year, but here our concern is, can I identify my equation from this here, just having this? And from the value that I get from it, will I be able to identify what kind of conic section, like what conic section am I working with? Is this like from that equation given, what conic section will it bring out? So in general, we know that we have a squared plus bxy plus c squared plus that's going to be dx plus dy and plus f equal to 0. So you know this is your a, that's your b, that's your c. So you replace here and you actually work out. But our concern is if you have b squared minus 4a squared like this here, the value, if the value that you get here, if the value that you get there is going to give you a 0. If this gives you 0, then you know that this equation actually given in the question is a equation of what? Of a parabola. And as we saw in this assignment here, that it is indeed a equation of a parabola. And we actually worked out and we got to see that equation that, oh, it's actually an equation of a parabola. Then if this here, I work out and the value that I get, this value that I get something that is less than 0. So meaning 0 0.2, 0 0.1, 0. It's just less than, not 0 0.2, I mean like that's something less than 0, like a negative value or so, -1, negative what, then you know that this is going to give you an ellipse. It gives you an ellipse or a circle. So you know that the equation, this equation you're given, is either of an ellipse or of a circle. And when you work out, so this helps, this guides you, like when you're doing that rotation and you're changing to the x prime, y prime, it gives you a guide to say, okay, what I have to get in the end goal, because I've done this turn, it has to give me this equation. So as we knew when working that, okay, we have to get a parabola because it gave us 0. If it gave us something else, then we would have known that, okay, our working is wrong, we have to revisit our work. Then lastly, if it gives you this AC, this is greater than 0, then you know this is going to be a hyperbola. Not a hyperbola, it's going to just be lines that intersect, like lines that cross like this. Yeah, so this is what you get. Unless there any other question that's there. Okay, since there are no other questions, then we will end here.